Okay, our next problem, we're going to be given this triangle, and they're telling us that they want you to find or evaluate this triangle, the cosecant of the 45-degree angle. Okay, so there's your problem. Evaluate the cosecant at 45 degrees. They're telling us that this angle up here is our theta, and that this angle down here is 45 degrees. And they're also telling us that this side is equal to a length of 1, from here to here is 1, and this side is the same. The length from here to here is also 1. All right? So they're giving us this problem, and they want us to find the cosecant of the 45-degree angle. Now, here's what I suggest. The first thing you want to do, if they don't give you all three sides, is find the third side. Then we'll label our sides in reference from location from the angle in question. The angle in question in this problem is the 45-degree angle. So we're going to end up labeling our sides from this angle here. This side will be directly up, etc., etc. Before we get to that, though, let's go ahead and find the missing side. The side that's missing is called the what? Is it one of the legs, or is it the hypotenuse?
The hypotenuse.
Very good. So we want to find the hypotenuse, because that side is missing. So before we apply our trig definitions, let's go ahead and find the third side. So we have to use c squared is equal to a squared plus b squared. When finding the hypotenuse, what I like to do, one of the things that you can do is start by right away by taking the square root of both sides. So that's what I'm going to do for this problem. I'm going to take the square root of the left side and set it equal to the square root of the right side. Now, what do we get over here? What is the square root of c squared, Marco?
C.
Good. Now, on the right side, there's nothing we can do. So now we have c is equal to the square root of a squared, the quantities a squared plus b squared. This formula is an offshoot of the Pythagorean Theorem. All we did was take the square root of both sides. But this is the formula that you can go directly to when you're trying to find the hypotenuse. Okay? So I like to use this form of Pythagorean Theorem for finding the legs, and I like to use this form for finding the hypotenuse. It's just two different forms of the same equation. Okay? So let's plug in to this formula right here. We want to label our sides A, B, and C. The hypotenuse has to be side C, lowercase c, and the other two sides, the legs, either one can be A or B, but once you label it, you want to stick with it. So what should we label this side here? And what should we label this side down here?
Right.
Good. Now, again, the hypotenuse has to be lowercase c. That's automatic, but either the two legs could be A or B, but once you label it, you stick with it. Now, we've got to plug these values in to our Pythagorean Theorem. So we have c is equal to the square root of. Now, we're going to plug the a value in here, and we're going to plug the b value in right here. So what number should I plug in for a?
1.
What number should I plug in for b?
1.
Good. Now, we end up with c equals, what is 1 squared? 1 times 1 is
1.
plus, and so we get c is equal to the square root of what number?
2.
There you go. So there's our hypotenuse. It's got a square root in it, but that's okay. If it can't be reduced, we leave it. There's the hypotenuse. Like I said, all of the sides are not always going to be nice round whole numbers. And this shows you that. Sometimes the sides will have fractions or square roots in them. That's why that 3, 4, 5 is such a famous triangle, because that's one where all three sides are whole numbers, and it's the smallest whole numbers. All right, so we have c we found to be the square root of 2. So now we can apply our trig definitions to answer the question. However, the cosecant, what was the definition for the cosecant? Well, I don't have them memorized. If you have the sheet in front of you, that's fine. I do know that the cosecant is the reciprocal of the sine. I remember that the sine of an angle is equal to, what was the definition for sine? Opposite over, good. So the cosecant is the reciprocal of the sine. So to get the cosecant, we have to take the reciprocal of this part right here. What do I get?
The hypotenuse over the opposite.
Good. So this is what we have to plug into to answer the question. So let's label our sides in reference to the angle that they're looking at. It's important that they're looking at what angle in the problem?
45.
Yes, the problem is right here. Evaluate the cosecant of the 45-degree angle. So basically, they're saying we have to label everything in reference to this angle right here. So what should we label side B, which is directly what from this angle?
Opposite.
Very good. Opposite, nicely done. And what should we label side A, which is next to this angle, but not the hypotenuse?
Adjacent.
Adjacent means next to, exactly. Good job. And so this side directly opposite the right angle is the hypotenuse. So now all we have to do is plug our values in. The cosecant of the 45-degree angle is going to be the hypotenuse over the opposite. So that's what number over what number?
It's square root of 2
over
1.
Good. That's the hypotenuse over the opposite. Now that just ends up being equal to what?
Square root of 2.
Yeah, anything over 1 is itself. So there's the answer to our problem. Good job. Are we okay? Okay, next problem. All right, now on the next problem, they're going to give you the sine of an angle and they're going to give you the cosine of the same angle. Okay? So in this problem, they're asking you to find a tangent. Let's go ahead and see what they're giving us here. All right, they're telling me that the sine of a given angle, theta, is equal to a fraction. Now it's important, when they give you the sine or a trig function is equal to a fraction, you're going to set it equal to the definition, and I'll show you how to proceed from there. So the sine of our angle, we're given, these are the givens. We're given that the sine of our angle is 3 over 5, and we're also given that the cosine of the same angle is 4 over 5, and they're asking you to find the tangent of your angle, of the same angle. That's what they're asking you to find. Now, whenever they give you either the sine or the cosine in fraction form, how I suggest that you proceed is to write the definition right next to it. What is the definition of the sine of theta?
Opposite over hypotenuse.
Good job. And what about the cosine of theta? What's the definition of the cosine of theta?
Adjacent over hypotenuse.
Good job. Now the reason I had you do it like this, whenever they give you the sine and cosine in fraction form, now we can see that the opposite is equal to this number and the hypotenuse is equal to this number and the adjacent is equal to the numerator here and the hypotenuse is equal to the denominator. So now we want to make a drawing of a triangle. Okay? So now we go to our drawing of a triangle and we label the sides and we're going to plug the values. We're going to plug the values right onto our drawing. Now, here's our right angle. I'm going to label the side directly opposite the right angle, as the hypotenuse. Now, I'm going to pick one of these two angles to be my theta. I have a choice now. So I can pick either one. I'm going to pick this one down here. There's my theta. Like I said, I had a choice. Now, if this is my theta, then this side is going to be labeled what?
The opposite.
And this side here, next to my angle, is called the,
Adjacent.
yeah, we label it adjacent. Now, the nice thing now about this drawing is we know the values to plug in, because when we set up the fractions and put them equal to the definitions, now we know that the opposite is equal to 3. So I'm going to put that right here. Opposite is 3. We know that the hypotenuse is this number here, 5. I'm going to put that right here. And we also know that the adjacent is the numerator here, 4. And we also know one last thing, that the hypotenuse is equal to what? 5. Well, we already have that, so that's good. That works out perfectly. Now all we have to do is apply our definition for the tangent to answer the question. What is the definition of tangent of an angle? What over what?
Opposite over adjacent.
So opposite over adjacent. So what number over what number for this problem?
It's 3 over 4.
Good job. Opposite is 3, and the adjacent is 4. And there's your answer. All right, good job. Very good. All right, the next problem is very similar to the one we just did, except they're now asking you for the secant of your theta. Okay?